In this video lecture, we are going to understand the sway concept and analysis of frame using moment distribution. So first of all, consider a frame member subjected to a horizontal load, let us assume, and both the supports are fixed. Due to this horizontal load, the structure will be subjected to a horizontal drift for an amount of delta, and also the resultant moment direction is like this. All the directions are anti-clockwise, and due to the delta settlement, the moment component created is 6EI delta by L square. So you might be remember the slope deflection equation, that is 2EI by L theta A 2 theta A plus theta B minus 3 del by L when you write for the member MAB. For the member MAB, the fixed end moment MAB bar plus this term will come. If you multiply inside individual component, we will get 4EI theta A by L plus 2EI theta B by L minus 6EI delta by L square. So each of the component represented the moment values. So the moment occurs at A and the half of the moment occurs at B, and this term is due to the settlement or deflection. So this term will come here because of this settlement delta. So the moment formula to be taken as 6A delta by L square. For the different case, when one end is simply supported and one end is fixed, if you subjected to a horizontal load W, the same effect will be considered, but the moment will be different for the far end simply supported case. If you consider this is a joint, the far end is simply supported, then the moment here is 3A delta by L square. Here also 3EI delta by L square. This fixed end will create the same amount, that is 6EI delta by L square when the far end is fixed. This 6EI delta by L square. So you have to note this point that when the fixed support is given, the moment created due to the horizontal drift or delta deflection is 6A delta by L square, and anti-clockwise it's in nature. And for the simply supported case, it is 3A delta by L square. Because we are going to deal with this term, so hence we have to understand. And the sway analysis for the given structure or a frame comprising of non-sway moment, the calculation of non-sway moment. Second one, net horizontal reaction. You can indicate as H. Third one, sway moment calculation. Fourth one, net horizontal reaction due to sway. Due to sway, that is H dash. And the correction factor, we have to calculate the correction factor H divided by h dash, because initially we are analyzing the given frame as a non-sway frame and calculated some reactions, horizontal reactions, because for a horizontal load there will be a horizontal reaction at A and D in different magnitude. It will not be same magnitude, there will be some difference HA and HD. So we get the net horizontal reaction as HA plus HD if it is same direction, or HA minus HD if it is different direction. So here I am considering both are towards the left side, so I have added this quantity HA plus HD. So this is H dash. It is from the non-sway analysis. And you consider some sway moment and analyze the frame using moment distribution method by constructing the moment distribution table and calculate the net horizontal reaction H dash and calculate the correction factor, that is the ratio between non-sway reaction divided by sway reaction. Then the final moment equal to, we can get non-sway moment plus the correction factor. Let us make it is R, the correction factor R into sway moment. So this will be the final moment value. So if you consider in reverse process, we want to analyze the beam to find the final moment. For that we have two procedure. One is the calculation of non-sway and the sway moment using the moment distribution table. And from the non-sway moment we have to calculate H. From sway moment we have to calculate H dash. And if you divide the H by H dash term, you will get the correction factor which is to be applied for the sway moment. So this is the overall procedure for the sway analysis. So if you given with some problem like this, you consider the normal procedure for the non-sway moment, and for the sway moment calculation, you assume 6EI delta by L square as some value, that is you can take 100 kilonewton meter. So you have to assume the fixed end moment in the sway calculation. Let us elaborate this. First one, non-sway calculation. For the non-sway calculation, if you consider one frame with the UDL, you will get the fixed end moment value for the span m bar AB equal to m bar BA equal to, so let us make some correction. Here first support, you keep the first support as A, second one is B, and m bar CD and m bar DC. So all the fixed moment values are 0 because there is no load in this area. Only we will get m bar BC and m bar CB. You will get some value in kilonewton meter. So after calculating the distribution factors for the joint B and joint C, we can make the table joint, member, distribution factor and the fixed end moment. For that A, B, C, D, and you will have the members BA, BC, CB, CD and DC. Here it is AB, and you will substitute the distribution factor and you will have the moment, fixed end moment. Here AB 0, BA 0, CD and DC 0, and you will have some value for BC and CB. And you extend the process to get the non-sway moment for the final moment. So this is called non-sway moment. So from this non-sway moment, you calculate the horizontal reaction by using the moment value. If you have this moment direction and here also in this direction. You assume HA and HB, and you take moment about B equal to 0 to find HA. Similarly, you consider the column C to D and its corresponding moment values, and you assume some direction HD, here HC, taking moment about C equal to 0 and find the HD value. Here I am assuming both the directions are towards right. If you got similar answer, HA will plus HD will be the net horizontal reaction. So the horizontal reaction should be resisted by the applied load. So the load should be applied opposite direction to the horizontal reaction. If it HA and HD in this direction, the sway force should be assumed in this direction to counteract the horizontal reaction. So you keep this is H only. This is not H dash. It is H only, and you extend for the second step, that is sway calculation. Sway calculation, and this, as explained earlier, both the columns are subjected to the sway condition like this. This is A, B, and C, D. The beam is not subjected to the sway, only column members are subjected to the sway condition. So we assume the fixed end moment value M bar AB and M bar BA and M bar CD and M bar DC, which is equal to minus 100. Let us assume some value of fixed end moment for the sway condition. We can assume minus 100. Why it is minus? Because we know the direction of this moment is always clockwise. So I am assuming negative value for this minus 100. And you formulate the moment distribution table, that is joint, member, distribution factor, and fixed end moment for the member A, B, C, D. The member is AB, BA, BC, CB, CD, and DC. And you substitute the distribution factor, and the next one, the fixed end moment value. I am considering MAB bar and MBA bar, MCD bar, and MDC bar, which is equal to minus 100. So you substitute minus 100, here minus 100, and minus 100 and minus 100. So you keep this is the fixed end moment values, and to continue the process to get the final sway moment. If you continue the process of iteration, you will get some moment finally. That is the final sway moment. And the same procedure should be repeated. You consider the column and you draw the respective moment direction, and also you draw the horizontal reaction direction. You assume, first of all, you assume the direction of horizontal reaction. According to the results you obtain, you can change the direction. You take moment about B equal to 0 and calculate HA dash. You can say it is HA dash. Similarly, for the member C and D, you mark the moment values. So I am just drawing an approximate assumed value, and you make the direction HD dash. Take moment about C equal to 0 and find the value of HD dash, and find the net horizontal deflection, that is H dash equal to HA dash plus HD dash. So previously we got H, here H dash. So the third step is to find the correction factor R equal to H dash by, sorry, H by H dash, H by H dash. So in the next step, we can obtain the final moment, that is first one non-sway moment, next sway moment, next one final moment. By using the correction factor R, we are going to calculate. So if you get some value of non-sway moment of 100 and sway moment of 50 and correction factor of 0.5, the final moment value is 100 plus 0.5 into 50. So this is the final moment. So I am writing for an example. In a real problem, we can calculate this value. So this is the procedure. We can recall the overall procedure. For the sway analysis of frame, we have to find first non-sway analysis, and you can calculate the bending moment value and H value. Next one, sway analysis. You calculate the bending moment and H dash, and you find R is the correction factor, that is H by H dash, and make a table like this. You calculate the final moment. The final moment is equal to non-sway moment plus correction factor into sway moment. So this is the shortcut procedure you have to remember. So with this understanding, we are going to do the problem in the next video.